Hi, and welcome to this video. In this video, we're going to be talking about arithmetic sequences. So what even is an arithmetic sequence? So let's take a look. Let's say that I had the numbers 1 through 5. Pretty simple. 1, 2, 3, 4, 5. And if you noticed, I add 1 to get to the next number. So 1 plus 1 is 2, 2 plus 1 is 3, and you continue adding 1 to get to the next number. This type of sequence is actually pretty common in math. You actually call this an arithmetic sequence. So you might see this in your math or in the real world, but because this is so popular, it's called an arithmetic sequence or an arithmetic sequence. And what essentially it is a sequence of numbers which are just added by the same common difference. So in this case, it keeps just adding with 1. So 1 is the common difference. So let's write a more generic version of an arithmetic sequence. If the first number is a, let's say a is like that first number in arithmetic sequence. To get to the next number, I'm going to do a plus d, that's the next number, because the common difference is d. So to get to the next number, that's a plus 2d. To get to the next number, that's going to be a plus 3d. And you're going to continue doing this into a plus something. We don't know quite what that is, whether it's n minus 1 or n, times d. And in that parenthesis, it might be confusing what that is. You might think it's n. Well, because it's the nth term, and that makes sense. But that first term, if you notice, that first term is actually a plus 0d, which is the first term, meaning that that last term is actually n minus 1, because the first term starts with 0d. So when you actually write that last number, it's going to be a plus n minus 1. Oh, whoops, sorry, small mistake there. But n minus 1 times d. Okay, great. Now that we understand that last number, you're going to notice that you can take that first sequence and convert it into a plus n minus 1 times d. So I just rewrote the generic version right on the board here. And like I just talked about, that last number is going to be a plus n minus 1 times d, where the first number is a, the difference is d, and the number of numbers is going to be n. So you can use this when you're trying to find the last number, or let's say that you know everything, but you don't know n, or you don't know a, or you don't know d. So you can also use this to plug it back in and try to find the other values as well. So this can be really helpful when you're trying to find the arithmetic sequence, both the first one, the last one, or any of the other crucial pieces inside an arithmetic sequence. So let's say that I was buying some shirts, and the first shirt is $11, the next one's $13, the next one, let's say, is 15, 17, 19. So in this arithmetic sequence, how am I supposed to find the sum of all the shirts that I want to buy? Well, this is where you might start adding it. 11 plus 13, 24, and you might start adding all the numbers, and you can see it's getting really tiring. And these are only 5 numbers. What if I had the numbers 1 through 100? I don't think that I'll want to sit and add up numbers 1 through 100. So when you're adding the arithmetic sequences, there has to be some clever way to get to 75. You saw that I had to do a lot of work. So let's see whether there's some clever way to do it. Well, I know a clever way. Why don't we just use our calculator? Right? That's going to be so smart because in my calculator, I can go 1 plus 2 plus 3, and I can add really, really quickly. My calculator is going to do all the math for me because but the thing is that you'll notice like here, let's see whether we can, like when we're adding it, we're adding it in pairs. We're kind of adding 1 plus 13 first, then that with 15. But that type of pairing doesn't quite work because you're going to notice that it's kind of heavy. So using a calculator is also a fail. You can see like in the calculator, it might take a long time to punch in numbers. And you're also using this pairing system that takes a long time to add. So Mm, let's see a third way. Method 3 is actually one of my favorite ways because it's from a mathematician called Carl Gauss. And what he was tasked, his teacher asked him to sum up all the numbers from 1 through 100 because she just wanted to grade some papers and she just wanted to keep the kids busy. But the second she asked it, almost a couple seconds later, he instantly yelled out the answer. He yelled out 5050. And how could he do it so quickly? Well, that's where he actually used his clever arithmetic sequence strategy. He took the first number and the last number and added them, got 101. And you notice that, wait, that's kind of confusing. But if you take the second number and the 99th number, you get 101 too. So you're kind of pairing the numbers in a different way that has every pair have the same sum. You can notice that it all has 101. And when you're pairing all the numbers, there's n numbers, but there's n divided by 2 pairs because there's 2 numbers in every pair. So to find the sum, all you have to do is take the value of the pair and it times it by the number of pairs, which is the number of numbers divided by 2, which is 5050, just like he said. So you'll notice that this method is much more faster and much more efficient. So let's see whether we can use that in our sequence. Well, when we try to pair the numbers, you notice that we have 30 for the outer ones, we have 30, but then we have this 15 in the middle, which doesn't have a pair. Well, you can actually still use that same n divided by 2 because there's 5 numbers and you divide it by 2 and you have 2.5. And that 0.5 considers for the middle one not having a pair. So what you do is that you take 30, multiply the number of numbers, and divide it by 2. And when you solve this, you get 15 times 5 because 2 and 30 cancel. And then because you'll notice like the 5 over 2 is 2.5, we can cancel and then we can get 75, which is the same answer that we got way back when we were using that first method, or you might pause the video, done the second method as well. And you notice that this is much faster way to find the sum. So let's find a more generic way to write this. Well, it's the number of numbers divided by 2 plus the first plus last on the numerator. And when you see this, just think that the n over 2, that's the number of pairs. And so you don't so the number of pairs is n divided by 2. And the first plus last f plus l is what the pair value is. Remember, it's just the first number plus the last number, that's the value of the pair. So when you see this formula, it's the same thing that I just showed you. Let's take a look at this new problem. And let's say that I want to write the numbers 1 through 100 in a really fancy, easy way. That's where you use this, 1 through 100. But this is so confusing. What even is this? I mean, you can do 0, 1, 1. This is so confusing. We just went from sum to confusingness. What does this mean when I do this weird symbol with numbers all around it like a surrounding thingy? So let's see what this actually means. So in the middle, this sign right here, that means the sum of arithmetic sequence or the sequence that you're given. That Greek symbol, it's the sum of the sequence. You can also take a look at that bottom number because that bottom number is going to tell you the first value of k. Wait, what? What's k? And you also might see it like k equals 1, and this might get confusing as well. But if you'll notice, you can see like beside the sum of sequence sign, there's a k. So 1 is the first value of that k. That k that I'm just referring to is the actual sequence itself. It tells you you take the 1, you plug it into that sequence, you get the first number in the sequence. You plug 1 into k, you get 1. That's the first number in 1 through 100 key sequence. So that way you can get all the way from 1, 2, 3 as the number increases. But when do you know when to stop? That's when you look at that top number. That top number is where to stop. It's the last value that you plug into k to get the last number in the sequence. So you'll notice that we have 100 to k. 100, when you plug that in, that's the last value. So I hope that this kind of explained it for you, like the sum of the sequence, the first value of a sequence, and like kind of stop. But once you understand this notation, you might see it on your worksheets. You can understand how to quickly find the sum after you write down the sequence. So if you learned from this video, don't forget to put a thumbs up, put a comment on what you learned, what you thought was cool, and subscribe to my channel for new videos and updates on what else I have to teach you next. I see you next time.